equally sized, same functionality. And you look at the difference on that yellow card, and you see a difference ranging from 300 kilowatt hours per year to over 1,000 kilowatt per year. Just the way it is designed. Nothing to do how well it works, don't get me wrong. There's no reason for us to lower our comfort level. There's no reason for us to do with less. We are intelligent, brilliant people. We can do anything we want. We can send people to the moon. Or surely we can develop a more energy efficient refrigerator. So it has to start somewhere. It has to start here. It has to start with you understanding that we don't have such a thing and we need such a thing, and you need to build up the demand to the point that the supply will follow and regulatory issues will help, and then we get there. All right. By the way, this is the a close-up of these pipes running along the ceiling with the cooling fins. This is an exposed section. I'm not going to talk about this. How are we doing for time, boss?
You got 25 minutes.
You're supposed to give me half time.
You said 10 minutes and 5.
No. Okay. I'm going to talk now about what's happening at the farm. Because that's what the title said on the paper. Otherwise I can't come back next year. What's under the hood of a solar system? Well, basically, half of the money's on the roof and half of the money's in the basement, or somewhere in a little room. And that's if we are off the grid. Off the grid means that we have to store the energy for the times that we don't have sun, unless we want to go to sleep when the sun goes to sleep. And that's normally not practical. So we need to have a battery bank, a room full of batteries, depending how big our system is, to store the energy which we generate during the light hours of the day, and then we can use that at night and in dark days. I mean, in December we may not see the sun for weeks. That doesn't mean that we don't have light. We do have light, but we have only a little bit of light. So we have to have a buffer we can take energy from in these dark days, and typically that means that we have to have a buffer for 5, 6, 7 days of energy, so we can get through the winter months. So we have at least one solar panel, normally more. We have at least one battery or more, and there's only two other pieces of equipment we need. One is called a charge controller. It controls the charge of the battery. It makes sure the battery doesn't get overcharged, and it makes sure that the battery doesn't get discharged at night. And in addition, it gives some interesting information about how much power am I generating from the sun, how much power am I using, and what's the difference. In other words, do I have a little buffer, or am I running a deficit? More cup of tea. The only other box is this yellow square here, which is called an inverter. An inverter inverts battery power, like what we have in our car, 12 volts, to what we call household power, 120 volts, what we have in our outlets, or maybe double that, 240 to run our dryers or air conditioners. So that's simply a box of electronics which makes sure that we can run normal appliances, normal lights, normal tools. We don't have to buy camping gear in order to live off solar power, which is more of a practical issue. We don't want to live it ourselves. Like I said earlier, we have no need to lower our level of comfort. As a matter of fact, we want to increase the level of comfort. You can imagine the solution I've just illustrated about cooling your home without air handlers and blowers and registers, which would be far more pleasant for a person to be in than a mechanical system which makes noise, which distributes the cold and hot air unevenly and has many other limitations. One other thing which has happened in the last 10 years, as more and more people are implementing small-scale solar systems, is that some of the large-scale capabilities which are in our national grid are beginning to be available to small-scale systems. And let me give you an example. I told you that we started with 2 batteries and 2 solar cells, solar panels at the well, and then we started building a home which was pretty far from the well, so we put a set of solar panels on the home, and then we would have loved, in times of drought like we've just had for 5 months, to be able to have the power which was generated by the panels on the house to feed the water well during the day when, you know, we need all the water we can pump. And vice versa, on Saturday night when my daughter has a big party, lots of light, lots of sound, lots of things, the pool is running, we would love to use the power which is available at the well system, which doesn't need a lot of water at midnight, to help supply those energy needs. But that was simply technically not possible. The systems were separate, they were incompatible, you couldn't connect them together because you would lose a lot of power. Well, in the national grid, that's what happens. We have power plants all over the place, we have people all over the place, we have different needs at different times of the day, and somehow it's all working. Which is because we have a very sophisticated control system to do that. We can borrow and lend energy to whoever we need by simply making an automated control system. It's no longer pressing button, it's all automated. So if there is a power crisis in California, then all the utilities in the east can send energy there to try and relieve that shortage, and vice versa. It's an automated process. So these capabilities are slowly making its way into the small-scale systems. And I'll give you an example. That yellow box which I illustrated earlier on, which is this one here, which is basically the interface between the solar panels or the wind turbine and our electricity system where we plug our things in, can now be connected to other inverters. For instance, I can now buy an inverter at the well and an inverter at the main house and connect them together just like all our electricity wires are connected together, and I can send power back and forwards. I can do the things I wish I could do 5 years ago. So that's a great improvement. And that's again because demand has made its way up in the supply chain and we are able to reap the benefits. So those are important things. We can now, for instance, at a place where my wife just cleared another 5 acres, put up a small wind turbine because she said there's apparently a lot of wind there, and help to charge the main batteries of the house. And it'll all happen automatically. These are some numbers of what's going on right now. We have almost 7 kilowatt in panels. I think we have actually some more by now. Which in terms of what you use right now in your home is probably nothing. I mean, a typical electricity bill around here in the tent will probably run anywhere from $100 to $300 a month. All right? And the typical price of a kilowatt hour is between 10 and 20 cents. So we're talking about using 10,000 kilowatts a month, right? And I'm talking about generating I have 7 kilowatt of solar panels and I have about 5 hours of sun a day in this part of the country. So I can maybe make 5 times 7, 35, let's call it 33, times 30 days. That's about 1,000 kilowatts. So all my efforts, I'm only making 1/10 of what all of you in this tent are using. And I'm doing good. I can irrigate 10 acres. Why? Because I use energy different. I had the luxury to start from scratch and to design from zero. And in everything we did, we considered the use of energy. what is the best way? How can we minimize electricity consumption? No electric heat, that's wasteful. If we generate power by generating heat and then boiling water and taking steam and then turning a generator and then using that generator to make heat, we're doing something wrong. Doesn't make sense. We've just lost 2/3 in making that electricity and we're going to start all over. We're going to kill ourselves. So electric heat is a no-no. We need to use other sources of heat, which we have. Natural gas, clean burning fuel, available right here. Propane gas is an alternative if you're not in the city. Wood, some other sources. But for the majority, simply go to gas. I want to show you what we're doing for time.